This is the video lesson for limits day 2 notes. On this first part, we have some limits that we've seen before in day 1, but this is to use the table feature of your calculator to evaluate the limit. Now, I just want to kind of recap from day 1. If you were to plug in -1 here, you might, if you just do some quick number crunching, you can see that it's going to be 0 over 0. And that we know then there does exist a limit. We just have to do a little bit of work to figure out what it is. Okay, so remember algebraically, we're going to do this before we do the table. Algebraically, you would need to factor. This becomes x plus 1 times x plus 2 in the numerator. And in the denominator, we end up getting x plus 1 times x plus 3. So the whole reason we had 0 over 0 is because there's a hole at -1, and when we cross that off, we can easily just plug in -1 in for x. There's no discontinuity anymore. We removed it. So we end up getting 1/2. Okay, so this is a problem that you can do algebraically without a calculator. So let's look at what it would look like on the calculator and compare our answer, which we know it should be the same. Okay, the table. Probably your table is set up like mine where it's going by ones. And if we approach -1, we can obviously see that there's an error, but that doesn't really tell us what the limit is. Okay, so what we're going to do is we're going to go to our table. We need to go in smaller increments. So whatever your limit, the x is approaching, put that at your table start, and then change your increments. We could change it to 0.1. We could really change it to anything less than that as well. So let's see if this is enough. So now I'm going to scroll up just so we can see it from both sides. Now you can see that from the left and from the right, as x approaches -1, the y is approaching 0.5. And like I said, if you go back to your table start again, you want the table start to be -1. You can make this be 0.05, and then the increments would be a little bit smaller than that. Okay, and that might even help you see it more clearly. Okay, so the smaller that delta t or the delta x is, the more definite you'll know what your limit should be. Okay, so 0.5, 1/2, same thing. All right, on number 2, what happens when you plug 0 in? Okay, just like in number 1, you got 0 over 0. That's the same thing that happens here if you plug it in. Sine of 0 is 0. This means that there is a limit. We just have to do a little bit of work to figure it out. And I can't factor or anything convenient like that on this one. I'm going to have to do this one in my calculator. It's the only way I know how to do it right now. Okay, so we're going to type in sine of x divided by, and make sure you put that 5x in parentheses so it knows to divide the 5 and the x. And we want our table to start at 0 this time, and I'm going to go ahead and leave my increment really small like that. Let's go to the table, and you always want to go up just a little bit because you want to be approaching it from the right and the left, and we can see that it's approaching this number. And if you really weren't sure, if you were thinking it really was just 0.1999, you could make that increment smaller, but it is going to be 0.2. Let me go ahead and make it 0.01. Whoops. Sorry. Let me go ahead and make this 0.001. The smaller it is, the more detailed it'll be, and we always need to make this be what your limit of x is approaching. Okay, and so I can see more clearly, and in fact, it'll go ahead and just round up to 0.2. All right, so let's record that down. So we could write 0.2. You could write it as 1/5. It doesn't matter. Okay, so let's look at number 3. Do you think we could do number 3 without the calculator? Well, sure. If I plug in 3, I get 0 over 0. But if I factor, I get the limit as x approaches 3. And I realize that that says n. It looks like it says n on this one. Maybe yours, maybe I corrected that and that's corrected on yours. I'm hoping. Corrected if it's not, though. All right, so then when we get 3 minus x, down here I get x minus 3. And x plus 3. Now, it doesn't look like anything cancels, but we know that this 3 minus x really is x minus 3, but just with a factor of -1. All right, so we've removed the discontinuity. So now all we would have to do is plug in 3. Well, the numerator is going to be -1 no matter what. The denominator is going to be 6. And this as a decimal is -0.167. And if you... All right. Okay, now we get to number 4. And this is the limit as x approaches 0 of 1 minus cosine x over x. And if we do a direct substitution, we get 1 minus cosine of 0, which is 1 minus 1, which is 0 over 0. So again, we get this 0 over 0. We know there's a limit. We just don't know what it is yet. And factoring will not help me on this. So this is where we go to our calculator. Okay, so make sure you put that 1 minus cosine x in parentheses, and I didn't say this earlier, but you do need to make sure that you are in radian mode. It would work either way, but it's going to be easier if you just stay in radian mode. Okay, so notice I didn't use parentheses on the x because it was just one thing. All right, now if I go to my table set and I want to start at 0, and I go to the table, it looks like I'm kind of approaching two different numbers. A negative number from the left and a positive number from the right. But there's still a lot of changing going on. So anytime you're just not sure, you can set, we need to make sure that that says 0. You need to set this to be even a smaller number. And if you wanted to just always start out with a really, really small number like this, I think that would be good. That would be fine. And it still looks like I'm approaching a negative number on the left and a positive number on the right. But you notice as the increments get smaller, so do these y values. Okay, what is -5 times 10 to the -5th, or 5 times 10 to the -5th? 0. Now, one is approaching from the negative direction, one's approaching from the positive direction, but it is the same number. Okay, so you have all these techniques to figure out what your answer is, and in this case, it is 0. All right, now let's move on to the properties. All of these properties pretty much work out how you'd think they work out. So we have this, the limit of f of x, and this is as x approaches c, equals L, and the limit as x approaches c of g of x is k. So we're just using these two letters to represent the limit, so we don't have to write out that whole statement each time. Scalar multiple. Scalar just means we're multiplying by a number, not another function or another limit. This b would be a number. It'd be a real number, and we're just going to multiply that to whatever the limit of f of x would be, which is L. So b times L. That's what that would simplify to. Okay, the sum or difference. So if I'm adding a limit of two functions, or I'm adding two functions and then taking the limit, or same with difference, you would just add or subtract, whichever the case may be, your two limits. All right, product works the exact same way. L times k. Quotient, L over k. It's very nice how this works out. And this would be exactly what you'd think it'd be. It'd be L to the power of n. So you can take this n off the power of the function and apply it to the whole limit. Okay, so here we get to just a little bit of application on this. So this is the limit as x approaches c of f of x is 9. That's kind of like the capital L from before. And then over here we have another limit that is equal to -2. So if you're trying to figure out, you know, we have no idea what f of x is, but we can find this limit by doing 4 times the limit of f of x, which was 9. So that is equal to 36. And these properties are going to definitely be useful in a little bit. All right, here we can just add these two numbers, add the two limits. So 9 plus -2, that's 7. And here I can take the limit, which is 9, and I can take it to the -3/2 power, which, if you remember, is the same as 1 over, because of the negative. The 2 is causing me to take square root of 9, and then I'm going to cube that number. So that would be 1 over 3 cubed, which is 1 over 27. All right. So now, number 6. This is algebraically. This means not with the calculator. Now you could definitely use the table feature of your calculator to answer the rest of these these next two problems. But let's do it algebraically. Always you would want to try to go ahead and do a direct substitution first. Now in this problem, plugging in a 0 would give us a 1/5 minus a 1/5 over 0, 0 over 0, indeterminate form. if there's something algebraically we can do, let's do it. If not, we would have to use our calculator. Now this implies that there is something we can do. Okay, I'm going to be really thorough, and every time I am going to write limit as x approaches 0. Right? And what I'm going to do is I'm going to take this rational, I'm going to look at the common denominator, which really, x is the denominator, but it's kind of like x over 1. So I'm going to take 5 and 5 plus x, and I am going to multiply that to the whole numerator and to the whole denominator. So I'm writing it first so that you can see that I'm not changing what it is, I'm just changing the way it looks. Okay, so the denominator was just x, the numerator was 1 over 5 plus x minus 1/5. Now we practice this a lot in this chapter, so hopefully you at least remember the basics of it. Okay, so now we need to distribute, and when I distribute this right here to the first term, 5 plus x is canceled, and I am left with just a 5. When I distribute to the next term, my minus first, the 5's end up canceling, and you are left with 5 plus x. Now notice that I'm using parentheses here because it's after a minus. And in the denominator, I'm just going to write it as 5x times 5 plus x. Just clean it up a little bit. Now, is there any more simplification I can do? Yeah, I can clean up that numerator. That becomes 5 minus 5, which is 0, minus x over 5x, 5 plus x, and just keep going. Because even at this point, if I were to plug 0 in, I would get 0 over 0. So look at that. I'm going to put a 1 in its place. And I'm going to go ahead and rewrite it, although I think you could figure out what to do next without me rewriting it. But this will make it look a lot better. Alright, now, if I plug in 0, I'm going to actually get a number. I'm going to get negative 1 over 25, and that is your limit. And you would get the decimal version of this number if you were to do this in your calculator, which you could check if you want, or have just for extra practice. Okay, so here we have a square root. Okay, again, if I plug in 0, I get 0 over 0. This means the limit exists. We just have to do a little bit of work. Algebraically, we can do something with these square roots, and we've seen it before even in our trig chapter, and that is multiplying by the conjugate. Okay, so let me just go ahead and rewrite what I have. Now normally when I multiply by this conjugate, it's because of the denominator. We're trying to simplify the denominator. But here I'm just trying to shake things up enough so that I can get some things to cancel. So I'm multiplying by the conjugate of the numerator. Remember, conjugate is just when you have a binomial and you switch the middle sign. Whoops, that should be a plus as well. Because these two things have to be the same in order for us to say that we didn't really change it, we just changed the way it looked. Okay, so now we need to multiply. Okay, it's almost like FOIL. Okay, square root of x plus 1 times square root of x plus 1, well that's just x plus 1. Square root of x plus 1 times 1, that's square root of x plus 1. Negative 1 times square root of x plus 1, that's negative square root of x plus 1. Negative 1 times positive 1, that's negative 1. So these things canceled. We knew that was going to happen. That's what happens when you do the conjugate. The denominator, I am purposefully not going to distribute. Alright, so let's think. I canceled these two. Can I cancel anything else in the numerator? Yeah, plus 1 minus 1. So I am left with an x in the numerator and an x parentheses square root of x plus 1 plus 1. And still, if I were to plug in 0 over 0, I would still get get 0 over 0. Okay, so I'm going to cancel this out. That leaves a 1 there. Okay, remember, anytime everything in your numerator cancels, you're left with a 1. And at this point, I can go ahead and plug in 0. I've removed the discontinuity, and the limit is going to be 1 over. And if I plug in 0 here, I get square root of 1, which is 1, plus 1, which is 2. And this is the same exact value you'd get if you were to use the calculator.